Hello, my name is Paul Thagard, and I'm going to be talking to you about the relevance of cognitive science to climate change. I think that climate change is the single biggest problem that the world faces right now. Pandemics are, of course, important, but that's going to pass in a year or two, whereas climate change is going to be increasingly important over the next few decades. Already we're seeing dramatic effects with things like extra hurricanes and wildfires in California. And so we're going to see many more such problems. The question is, how does cognitive science help with that? Well, I think it helps a lot, not because it explains how global warming works, but because it explains how people think about global warming. Now, that's important because we want to be able to change people's minds and behaviors. We need to be able to change the way in which politicians and other people work with climate in order to avoid the problems getting increasingly bad. My talk has also got a second point, which is I want to address the question of whether there is such a thing as cognitive science. That's been called into question recently. And I think that, in fact, if you look at the way in which cognitive science involving the interdisciplinary collaboration of a bunch of different fields can help us to understand how people think about climate change, you get extra reason to believe that cognitive science as an interdisciplinary enterprise is extraordinarily valuable. So my first point is, yes, we can understand how people think about climate change. My second point is this shows that cognitive science is very valuable as an interdisciplinary operation. Here's my outline. I'm going to start by identifying 4 questions about how people think about climate change that are important for helping people to deal with it more effectively. I'm going to show that there are also similar questions about COVID-19. My talk is not going to deal with COVID-19 very much, but the same kinds of questions arise. And so if you are interested in how is it that people can deal more effectively with COVID-19, you'll see that the kinds of answers that cognitive science can give are also important for dealing with the pandemic. Then I want to raise the question of the relevance of cognitive science. I'll discuss the skeptical issues that have been raised about whether cognitive science is actually working as an interdisciplinary field. But the way I'm going to show that those worries are mistaken is to show that with climate change, you really can get some good answers by being interdisciplinary in the way that cognitive science recommends. The first question I want to address is a question about theory choice. And why is it that scientists believe that global warming is caused by human action? Then I'm going to deal with the even trickier question of why are there climate change deniers? Why do some people remain skeptical? This is politically extremely important if you look in the United States, where the official government action is that climate change is not something to be worried about, despite the evidence that it's a massive problem. Then I'm going to deal with another problem, which is just as big. How do you change people's minds? It might be that if you just convince people that if they did theory choice right, then they'd realize that climate change is a serious problem. But changing minds is a lot more complicated than you might think. The fourth problem I'm going to discuss briefly is that when you try to get people to act concerning climate change, you have to deal with serious problems that are known in various fields as weakness of will or intention action gaps. And here, cognitive science theory of action is potentially useful for helping to get people not just to change their minds, but to act on what they've learned. The general point then is that in all these cases, theory change, understanding denial, understanding changing minds, understanding action, you really benefit enormously by having a unified approach to cognitive science where all the different fields collaborate to come up with answers to these very serious problems. Here are the 4 questions about climate change that I want to ask. The first one is, why is it that 99% of scientists believe that global warming is caused by human action and that the consequences for global warming are going to be very bad for large numbers of people? How do they use the evidence? How do they come up with these views? The second question, even more psychologically interesting, is why are there deniers of climate change? This is also relevant to questions such as, why are there anti-vaxxers? Why are there anti-maskers? We have to have an understanding of human psychology to see that in the face of huge amounts of evidence, there are still some people who want to maintain that climate change is a hoax, including the President of the United States. Given an explanation of why it's rational to believe that global warming is caused by human action, and given an explanation of why people are nevertheless denying it, we can then ask how people can be convinced. What can we do to change people's minds? This is actually very tricky, and we need psychology to investigate what actually works. And I'll have a little bit to say about that. I'll also briefly discuss the fourth question, which is paying attention to the fact that there are lots of people who believe that climate change is a serious problem, but nevertheless don't act on it, who are fully aware that the world now, and it's going to get worse in 10 years and worse after that, decade by decade, knowing that this is a serious problem, but they don't change their behaviors. They continue to drive big cars. They continue to take airplanes. They continue to waste a lot of energy. So what can we do to help people who actually do believe that climate change is a problem improve their behaviors? These are all good psychological questions that I think are best answered by a unified cognitive science. There are also similar questions that you can raise about COVID-19. Scientists are convinced that there is a disease and it's caused by a coronavirus, and the disease is certainly dangerous. But there are people who are basically COVID-19 deniers, the people who aren't paying attention to the evidence. So why are there people who want to say that, oh, it's just a hoax or it's not very important? President Trump was like that until he got sick himself. Then we can ask the same kind of question asked about climate change, is if we've got people who are denying that COVID-19 is a serious problem, how can we convince them that they're wrong? And then when you've got people who believe that COVID-19 is a serious problem, but they're not doing anything about it, well, this is actually behaviorally really an issue right now. Most people are convinced, but you still see people going to bars, hanging out with friends, not wearing masks. And so people's behavior, in this case, isn't keeping up with their beliefs. And so we should be able to say, from a cognitive science perspective, what is going to help them behave better. So what is cognitive science? A kind of crude definition, I don't really believe that definitions are very useful usually, is that cognitive science is the interdisciplinary study of mind and intelligence. So the interdisciplinary part is crucial. It involves at least 6 disciplines from the beginning, back in the 70s: psychology, neuroscience, linguistics, philosophy, computer modeling, and anthropology. Another word for computer modeling is artificial intelligence, trying to get a computer to do something that is like what people do when they act intelligently. So we're trying to study mind, all the different aspects of mind, including problem solving and learning and decision making and emotion, but also intelligence, which is where you are solving difficult problems and learning how to solve them better. The origins of cognitive science really could go back to the ancient Greeks. Plato and Aristotle, for example, were philosophers who were very interested in the nature of mind. And psychology really got rolling in the 19th century, as did neuroscience. But the historical origins of cognitive science as a unified enterprise really began in 1956. You might think it's odd to be able to date it to a particular year, but in that year, 3 amazing things happened. One was the beginning of the field that we now call artificial intelligence. Computers were very young then, but a conference took place in Dartmouth, New Hampshire, concerning how computers could do things that were more intelligent. And so the founders of AI were there: Herbert Simon, Marvin Minsky, John McCarthy, and several other stellar people. And that's really the beginning of the idea that computers might someday be as intelligent as human beings. In the same year, George Miller published a paper called The Magic Number 7, which might be thought of as the origins of cognitive psychology. You have to realize that in 1956, psychology was dominated by behaviorists. Behaviorists said, well, we're not going to talk about the mind. That's not scientific. We're only going to observe behavior. Cognitive psychology got its start when George Miller said, well, no, we can't explain behavior without figuring out what kinds of operations are going on inside the mind. So that's an old idea. Again, philosophers had often thought that way, and psychologists in the 19th century thought that way, but behaviorism had driven out talk about mind. Instead, they just wanted to focus on behavior. Cognitive psychology, that term was only coined a few years later, said, well, we're going to bring the mind back. And in fact, we're going to take ideas from artificial intelligence, ideas that were just beginning to be formed about how you can build up intelligent programs, and transfer them over to cognitive psychology. Other big thing that happened in 1956 was that Noam Chomsky performed a revolution in the field of linguistics. Linguistics had also been dominated by behaviorists, such as B.F. Skinner. The idea was that you could explain everything about human language use just by looking at their behavior, looking at the inputs and outputs. You don't talk about what's going on in the mind. Chomsky made a very strong argument that behaviorism was simply failing in explaining human use of language, which is highly creative and produces very complex kinds of structures. And he took ideas partly from logic, partly from philosophy, to show how the language explanations require much more complicated kinds of structures and processes. So I would date cognitive science beginnings to 1956, even though philosophers have been doing similar things and psychologists. There was also, in engineering, a field called cybernetics, which was starting to develop mechanical ideas about the mind. But 1956, I think, is the big start. However, the term cognitive science didn't come around until the mid-1970s. It was coined by a number of different people. And the idea then is to make explicit what was happening implicitly since 1956, is that you need to get people together from different fields to tackle the problem of the nature of mind. The Cognitive Science Society was formed, the journal Cognitive Science was started, and many universities started cognitive science programs. So that was really how cognitive science got going organizationally. I was very fortunate to be involved with cognitive science programs at the University of Michigan and then at Princeton University. And when I moved to the University of Waterloo in 1992, I started the cognitive science program there. But recently, people have been expressing serious problems with cognitive science, suggesting that it has failed to become a truly interdisciplinary operation. So a multidisciplinary operation is one where people just get together and talk a lot, but it being really interdisciplinary, there's got to be a much more integrated kind of working. And Rafael Nunez and a number of his colleagues from the University of California, San Diego, have published a couple of very trenchant papers suggesting that cognitive science really hasn't lived up to its promise. And they've actually got some good evidence that they point to. One of the things they point to is that the field, at least organizationally, has been dominated by cognitive psychology. If you look at the main conference of the Cognitive Science Society, which I've been going to since around 1980, and the journals such as Cognitive Science and Topics in Cognitive Science, they're dominated by cognitive psychology. Most of the articles are written by psychologists. You'll find occasional ones by people in artificial intelligence or occasional neuroscience or a little bit of philosophy and linguistics, but it's almost all cognitive psychology. So that suggests that the field actually isn't interdisciplinary at all. Another problem is that the great growth of cognitive science programs in the 70s and 80s really hasn't continued. There's still only a handful of PhD programs that are concerned with cognitive science. So Nunez and his colleagues are in one of the most successful, which is the PhD program in the Department of Cognitive Science at the University of California at San Diego. It's an excellent program, but there aren't that many of them. In Canada, the only PhD program in cognitive science is at Carleton University. Many universities have started some kinds of undergraduate degree programs. I started the undergraduate minor, but most don't have full BA programs. Those are still fairly rare. Now, those are all organizational problems, but there's a major theoretical problem as well, is that despite the fact that the 6 fields of cognitive science have been working together more or less intensely for decades, there still is no unified theory of mind. There's no agreed upon way across philosophy, psychology, neuroscience whether how we should think about the mind. So I think part of the organizational disarray reflects the fact that there is a theoretical disarray as well. People haven't come up with a common view of how the mind works. Well, I'm not going to try to address the sociological problems today, but I'm very interested in the theoretical problem because I think that one can be dealt with. I've tried to deal with it in 3 books that I published in 2019 that collectively I call a treatise on mind and society. The first one is called Brain Mind, and it's largely an account of psychology and neuroscience. The second one is on mind and society, and it's dealing with all the social sciences. It shows the relevance of cognitive science for anthropology, which is all from the beginning thought to be part of cognitive science, but lots of other social sciences as well as practical fields such as education. The third book, called Natural Philosophy, shows the relevance for the field of philosophy and shows how the traditional fields such as ethics and epistemology and metaphysics can all be greatly informed from cognitive science. So at least that's my attempt to show that neuroscience can in fact be unified at a theoretical level. The way I do it is by putting neuroscience, and especially computational neuroscience, at the beginning, because I think that there are a set of mechanisms that could be identified for how the brain works, mechanisms that can be specified with sufficient precision that they can be modeled computationally, that provides the unification. I draw heavily on Chris Eliasmith's work on theoretical neuroscience, which I'll mention later. If you do that, then in fact you can have a unified account of not just computation and neuroscience, but also psychology, linguistics, anthropology, and philosophy. In this talk, obviously, I can't cover the 1,000 pages of the Treatise on Mind and Society, but what I am going to show is that this unification provides answers to the key questions about climate change that I mentioned, and the same sort of thing I'm planning to do in an article I've been invited to write about COVID-19. Once you see that, then I think you can see really clearly the value of cognitive science, not just as a multidisciplinary operation where you've got a bunch of fields kind of talking to each other, but actually as an interdisciplinary operation where these fields are working closely together and producing results that no field alone could do. So let me start with the first question that I identified with respect to climate change that I think cognitive science is highly relevant. And the first is there's a clear fact in the world that almost all scientists believe that global warming is taking place, and it's taking place because of human emissions of greenhouse gases. Why do they believe that? Well, they believe that because there's lots of evidence. There are countless studies of warming across the world. There are hundreds of different studies that show that global warming is a real problem. But of course, that doesn't show that it's happening because of human activity. It's happening because of greenhouse gases. Well, the theory they provide is a mechanism which says why greenhouse gases lead to global warming. So it's not just that we know that global warming is occurring, we know why it's occurring. Now, how do you explain how they're thinking? Well, what you need is a theory that on one side is a philosophical theory because it's saying this is the logic of what's going on, but you also want to be able to say what's the psychology because you want to explain why so many scientists have been convinced. If you go back 30 years, this was a new idea and a lot of people were skeptical about it, but now the vast majority, it's not even a majority, it's, I said 99%, have accepted the evidence and the theory that climate change is taking place because of human actions. Once you've got that theory, of course, then you can start to do something about it, and you can start to do the many things that have been recommended to slow the emissions of greenhouse gases. But first of all, you have to see why people believe that. Here's a diagram that gives a very succinct snapshot of what's going on. Now, this is based on my theory of explanatory coherence. So the theory of explanatory coherence says that when you've got a theory that you want to evaluate, any kind of causal attribution, it could be even things in ordinary life like why does your friend believe what your friend does, all these things can be explained by figuring out what's the most explanatorily coherent view. So this diagram gives a really simple example of explanatory coherence. The key hypothesis here is that humans cause global warming. And it's competing with alternatives. So the dotted line here indicates that there's a competing view that is a view that's held by the American leaders, used to be common among the Canadian conservatives, although they've since moved away from it, that we don't have to worry about global warming because it's just a natural fluctuation. And in fact, of course, there is natural fluctuation. Some years are warmer or colder than others. And so the claim is that we don't have to stop producing oil emissions because global warming is just a sort of natural occurrence. So that's the alternative hypothesis. Which of these is right? Well, I think there are two powerful reasons why we should believe that humans cause global warming. The first is it explains a lot of the evidence. It explains that global temperatures are in fact rising, and it also explains many, many other things. Here I've only listed one, that the recent temperature increases are rapid, so that the more carbon dioxide and other greenhouse gases there are, the more the temperature goes up. Then things are getting worse and worse. So we got this observation and countless others that you can find in the huge documents produced by the IPCC that will give you loads of evidence to believe that humans cause global warming. So that's one main reason. You can explain more with that hypothesis than the other. But you can also understand why humans cause global warming, how it happens, because you've got these higher level explanations that provide the mechanisms. The mechanism says there's a greenhouse effect that warms the planet. Basically, if the heat can't escape because of greenhouse gases, then you're going to get global warming. But we also know that humans have been increasing greenhouse gases dramatically over the last couple of hundred years. So the more gases you get in there, up there like methane and carbon dioxide, the more you get the greenhouse effect, the more you get global warming being caused by people. So we've got these two really good reasons, really three reasons. The hypothesis that humans cause global warming explains more than the other and explains a lot, and we can explain why it happens. So my theory of explanatory coherence shows how this works, but not just in a diagram. It's also a computer program. There's a computer program called ECHO that I wrote that can compute coherence. It can take into account all these additional effects plus some additional ones such as analogy. It was originally written as a neural network program, although there are other ways it can operate. But it was intended to be not just explaining abstractly in logical terms why it's justified to believe that humans cause global warming. It was also intended to explain this is how people are thinking when they realize that hypotheses are true, such as that humans cause global warming. And in fact, psychologists have done some experiments that show that, at least in some cases, such as social reasoning, explanatory coherence seems to fit quite well with the way human beings think. So we've got here a view that is philosophical, but it's also psychological, and it's also a neural network, and it's also computational, that explains why the vast proportion of scientists currently believe that humans are causing global warming. Now I want to emphasize how these contributions concerning theory choice are thoroughly interdisciplinary. There are at least 4 fields that contribute. Philosophy provided initial ideas about theory choice, understood as a kind of inference to the best explanation, and also ideas about how coherence provides the way of assessing what actually is the best explanation. Psychology has been absolutely crucial, theoretically, because it provided ideas about constraint satisfaction. This is the idea that you don't make an inference A, therefore B, therefore C, therefore D, but rather inference is a parallel process where you satisfy many constraints at once. This is an idea that was developed by early connectionists such as David Rumelhart. Psychology has also made the crucial contribution of behavioral experiments, because without such experiments, you don't have any reason to believe that this is how people might actually be thinking. Computer modeling was also essential to the whole operation. Explanatory coherence turns out to be fairly complicated because you've got lots of different constraints being applied all at once. When you develop a computer model, you can actually show that it is computable, that this mechanism is feasible. And you can also do simulations that provide complex behaviors that you can then compare against what you find with human experiments. I wrote a program called ECHO that served this purpose. It's a neural network program originally, although there's other versions that have been made since then. And what it does is enable you to take some very complicated examples, some with more than 100 different propositions, and show that you can get out a reasonable and efficient computation of coherence that gives usually the right answers about what is in fact the best theory to accept. The kinds of neuroscience used in ECHO was very simplified because the neural networks only had individual neurons representing whole hypotheses. But nowadays, with theoretical neuroscience, we can do this much more sophisticated. We could even put together a neural network that can represent something as complicated as global warming is caused by human action. So these are things that are now possible that weren't back when ECHO was formed. So I'll talk a little bit later about these more realistic neural models that are now possible. Now let's get to my second major question that I wanted to address. The second question about how you can explain, which is just as puzzling, why, despite the fact that there's massive evidence for humans causing global warming, that there are nevertheless people that deny it, including some very powerful people, such as the ruling government in the United States as of 2020. So I'll call them climate change deniers. They say that humans are not responsible for global warming. It's just a random fluctuation, so no actions need to be taken. So we don't have to change behaviors. We don't have to restrict greenhouse gas emissions. We could just keep going on happily as we are. So why do they say that? Well, some of them are just liars. And that's not psychologically very complicated. They know the truth, but they just conceal it because it's in their interest. And sometimes oil companies have been like that. It's just like what some tobacco companies did with respect to tobacco use causing cancer. There were tobacco companies who knew as far back as the 60s that their cigarettes were causing cancer, and they just lied about it. They had all sorts of ways of trying to manipulate the media so people do it. So I don't have anything to say about liars. They're just lying because they're trying to serve their own interests. That's not very psychologically interesting. But what is psychologically interesting is the phenomena that there are people who quite sincerely believe that climate change is not a problem. I mean, they think that they can't really trust the science, and so they're going to accept the leaders who are telling them that don't worry about it, and they'll want to be able to go about their business. You find a similar phenomenon with the anti-vaxxers. Most anti-vaxxers are good people. They're denying that vaccinations are good for people, not because they're lying, but because they actually are trying to do what's best for their children. They're seriously worried that if they vaccinate their children, they'll get autism. Now, their views are based on evidence. It's been completely discredited, but they keep on doing it anyway. But I don't think they're evil people. They're trying to think out for their children. They've managed to end up believing that vaccinations are bad. Something similar could be going on with some of the current anti-maskers. People are saying, oh, we don't want to wear masks. We don't want that imposed on us by the government. We don't think that COVID is actually that dangerous. Well, I think there are sometimes people who are sincerely convinced by not very good evidence. But the psychological question is, given that there is good evidence out there, given that there is really good evidence that wearing masks helps to reduce the spread of COVID, there is really good evidence that vaccines make children healthier, and there's extraordinarily good evidence that climate change is a serious problem that humans are responsible for. Why do they all believe that? How can we come up with a psychological theory that would account for that? Well, the groundwork was laid for this by a brilliant social psychologist named Ziva Kunda. She was a psychologist initially at Princeton University and then at the University of Waterloo, where she was in the Department of Psychology. And in 1990, just before she came to the University of Waterloo, she published a paper called The Case for Motivated Reasoning, which has been enormously influential. It's had a huge effect that's only growing more rapidly. It's now been cited more than 7,000 times, which is making it one of the most cited papers in social psychology of the last 3 decades. Sadly, Ziva's work ended prematurely. She died quite young in 2004. So I don't know what she'd be saying about this, but I'm sure she'd be seeing ways in which motivated inference is really important. I've known her work for a long time because we were married. So what's the theory? The theory that she came up with was that people tend to evaluate causal theories based on their own personal goals. That is, they're not just looking at the evidence, they're looking at what matters to them. So she did these really clever experiments in the 80s that would do things like this. You propose to people a theory and ask them what they think of it. And so the theory could be that caffeine causes cancer. What do you think of it? And what she found was, not surprisingly, that coffee drinkers were much less inclined to believe it. And on the other hand, people who didn't drink coffee, don't really care, they'll say, oh yeah, okay, maybe caffeine does cause cancer. I think her ideas about this were inspired, in fact, by her mother, who was a heavy smoker who was always declining to believe that smoking was really a problem for her family. She said, oh, look at my sons. My sons are more than 6 feet tall. And Ziva would gently point out to her, well, but one of them has bronchitis. So she was using motivated inference to think that her smoking, in fact, wasn't a problem. Now, the basic idea behind motivated inference has been around at least since the 17th century. Francis Bacon noticed that people have a tendency to believe what they want. But Ziva's work showed that it's much more than wishful thinking. It's not just that people believe what they want. They're not quite that stupid. Instead, when they have something they want to believe because of their goals, they will seek out evidence and arguments that support what they want to believe. So it's much more psychologically complicated than wishful thinking. You believe what you want when you can find the evidence that will support it. Now, motivated inference is something we all do. I do it. I know as much logic and probability theory as anybody I know, but I do it too. You do it too. And you just have to look at any field that actually matters to you, and you see that you're using motivated inference. That is, you're reaching conclusions not based on the evidence that's available to you, but on what you want to believe, what fits with your goal. So here's some examples across familiar domains. In romance, people often stay for unduly amounts of times with people who don't treat them well. And they can try to rationalize it. So, well, yeah, he's not being very good to me, but he'll change, or he's just under a lot of stress at work. So people use motivated inference to try to keep bad relationships going. Actually, there's major research by John Holmes and Sandra Murray, which shows that this is actually a useful thing sometimes in relationships, because people will perform optimistic inferences about their relationships, which keeps them going. Well, that's good for ordinary things, but it's really bad when, in fact, one person is severely mistreating another, and they're not recognizing it because of that. Also with parenting, when people really care about their parents, and sometimes they make motivated inference. They'll think that my child's not happy at school, but it's just a phase. It's something, it's just a bad teacher. And so they'll come up with explanations rather than that the son or daughter might have a serious problem, such as autism or some kind of personality disorder. Medicine. People have motivated inference all the time. They think, this little lump I've got, that can't be anything. When, of course, it might be cancerous. Or I've got a pain in my chest, but it's just indigestion. It can't possibly be a heart attack. So people are highly motivated to downplay medical problems and hope they'll go away. Politics. People do motivated inference all the time. People have a loyalty to a party, and so they can be convinced that the new leader is going to be really good, even though the new leader doesn't have a very good track record. Sports. People do motivated inference. I certainly do. Every season I want to think that my teams are going to do better than they actually do. Economics. People want to think that times are going to get better, that the recession will be brief, and that we're going to be able to have higher incomes. Not always true. Religion, I think, is heavily supported by motivated inference, because lots of things in life happen that are hard. We have to deal with disease. We have to deal with death. We have to deal with the other problems of life. But it's nice for people to be able to believe, it's okay, God will take care of me, or at least I'll get an eternal reward. Not much evidence for these beliefs, but loads of motivated inference behind it. Well, the notion of motivated inference was extremely influential in psychology because of the great evidence for it and the beautiful experiments done. But that's still not actually quite a matter of cognitive science. How can you turn this into a theory of how it actually works in the mind? Well, I think I did that with my theory of emotional coherence. So I started off with the idea of explanatory coherence, that people are believing what they do because it fits with the evidence and with their background theories. But realized that Ziva's work on motivated inference could be explained computationally by developing a theory of emotional coherence, which I did in my 2000 book, Hot Thought. So here the idea is when people form beliefs, they're forming them not just on the basis of the evidence and competing theories, rather they're looking to the emotional connections to their values and goals as well as the evidence. So the claim here would be that when people are denying global warming, they're doing it based not on the evidence, but based on their values. How this works is shown in very simplified form by this diagram. This diagram starts with the explanatory coherence diagram I had before that shows that people explain how global warming works in terms of humans causing global warming and believe it, therefore. But now this shows how nevertheless you can become skeptical about humans causing global warming. And here these thick dotted lines are showing a negative connection with goals that some people have of avoiding oil limitations and avoiding government intervention. So these two goals were very common among conservative politicians like Donald Trump. Doesn't like government intervention because he thinks that people should be free to do what they want. Doesn't want to restrict anything that the oil companies do because they provide a lot of money for his campaigns. And so why would somebody then let their values swamp their evidence? Well, it's again a matter of emotional coherence. If you think of these things as artificial neurons, it's obviously much more complicated than single neurons, but think of these as artificial neurons and think of these dotted lines as inhibitory links, then these goals are inhibiting the view that humans cause global warming. So the values that you have, the goals that you have of not restricting the oil companies and not having governments getting too involved are going to count against humans causing global warming. From the point of view of logic and justification, this is completely inappropriate because you shouldn't let your values affect your beliefs in this way. You should just look at the evidence and the competing theories. But in our minds, the way it works, you in fact get huge interventions where our values are swamping. And so people go looking for evidence that global warming is natural fluctuation. And companies like Exxon paid bogus researchers to generate all sorts of pseudo-evidence to that direction. So this, I think, theory of emotional coherence provides an explanation for part of how motivated inference works. Motivated inference works because you're not just looking at the evidence, you're not just looking at competing theories, you're not just looking at explanatory coherence. Instead, the coherence is emotional. It's with your values, the things that you care about emotionally, and that, in this case, is getting in the way of making a reasonable conclusion about what's going on. So that's work that was done around 2011, 2012. But since then, done some really interesting work that takes the theory of emotional coherence and makes it much more graphic, makes it much more visible. And I've done this in work with a group of political scientists at the University of Waterloo, put together by Thomas Homer Dixon. So the device that I came up with for doing this is a way of taking explanatory coherence and emotional coherence, but making it much more visible using a technique called cognitive affective maps. So I'll show you a graph shortly, but basically what we're going to do is use green ovals. They're green like a traffic light that says go, representing values that are emotionally positive. So for the sake of the people we just saw, they include values like let's not have governments get in the way of the oil companies. But for most of us, the values include things like let's make sure people don't suffer from climate change. On the other hand, when something is an emotionally negative value, we use red hexagons to represent the things that you just really don't want to happen, such as the millions of deaths that can happen because of flooding caused by climate change. We're going to use solid lines to indicate that the ideas fit together and dotted lines representing incompatibility. They don't have quite the same meaning as originally where they were explanation and contradiction, but they're showing emotional support, and incompatibility. And political scientists developed some really interesting applications of that. So I got a bibliography at the end of this talk where you can get the references. So here's one example that was put together by Manjana Milkereit, who was a graduate student at the Balsillie School in Waterloo, is now a professor at Purdue University in the United States. So she did some extremely detailed analyses of the motivated inferences that go on in the minds of people who are denying climate change. So this is a very detailed cognitive effective map of somebody who is skeptical about human-caused climate change. She's done ones that are way more detailed than this that involve 50 or 100 different nodes, but this gets a good picture of what's going on. So the green circles here, the green ovals, are all values and beliefs that are being the drivers of people who say, well, we don't have to worry about climate change. What we care about is we want economic growth, and we want wealth and private property and individual freedom and human individuals. And this is part of an ideology that wants to reject big government and taxes and things like that. But when you've got this package of values, it makes it much easier for you to dismiss all the evidence that supports the fact that climate change is caused by human action. The evidence that says, well, it is happening and humans are causing it. Instead, you get a bunch of claims that, oh, that's just bad science, or it's just scientists who are seeking grants. So I think that this cognitive effective map provides a really nice snapshot of what's going on in the minds of people who are doing it. But of course, it's not just a graph, it's not just a picture, because it's also a computational and psychological model, because all these circles, all these ovals and hexagons can be translated into a neural network that explains the mechanism operating in human minds. So it's not just a description of what's going on in the minds of people who are climate change deniers, it's also an explanation, because this can all be part of a computational process that's operating in human brains. It should be quite clear that the understanding of motivated inference and how motivated inference leads to climate change denier is a massively interdisciplinary contribution. You can't do this with just one field. In fact, in this case, there are at least 5 fields that are involved. Psychology was crucial with Ziva's experiments and her ideas about goals and memory. So psychology makes a great contribution. Philosophy comes into it because that was the origin of ideas about coherence and values. Philosophers talk a lot about values. Philosophy talks not just about what is, but what ought to be. It really requires values. Now, of course, I've given a rather different view of what values here. I don't think of them as absolute things operating in heaven. I think of them as brain processes, but nevertheless, ideas about values are crucial here. Political science was very valuable in bringing ideas about ideology, bringing in ideas that have been around in political science since the work of Karl Marx and continue to this day, that you have to see that the conflict about climate change isn't just a scientific conflict, it's also a question of ideology, with particularly right-wing ideologies wanting to reject the substantial amount of scientific evidence. Computer modeling was really important for this, because once you get beyond networks with more than a few nodes, it gets impossible to figure out what's going on, but there are computer models that can do it. So I expanded the explanatory coherence model that I mentioned into a program called HOTCO that introduces emotional reactions into the judgments of explanatory coherence, and that's had lots of different applications, many of which were in my book called Hot Thought, which is where the name HOTCO comes from. But more since then, the whole neuroscience of it has become much richer, because we can actually develop neural theories of emotions. My colleagues and I have done that in a way that I'll mention now. So in recent work, I've, thanks to the work of a lot of collaborators from different fields, been able to show that there are many mental mechanisms that can be understood by neural mechanisms, ones that are much more like the brain. They're not just simple nodes, but they involve ways in which millions of different neurons can interact. Here we've drawn heavily on ideas of Chris Eliasmith, which I highly recommend to you. He's got a wonderful book called How to Build a Brain that lays this all out. The theory of emotion that came out of this is a way of seeing how the brain can combine two crucial emotions, two crucial sides of emotion. One is what's going on in your body. There's lots of changes that take place in your body when you're having emotions. Your heart's beating faster, your breath is going faster, your palms are sweating. So that's going to be part of it. But it's also going to be that you're making a judgment about what is relevant about the current situation. But the brain provides an integrated way of what's going on, and we've got a nice theory of that. One consequence of that for understanding motivated inference is, I think, quite profound. So if you have a background in philosophy or economics, you might think, well, what's going on here is a confusion of probabilities and utilities. So probabilities are supposed to be judgments about how likely something is to happen, utilities of what it's worthwhile. And if you take expected utility, you can keep these things separate and then combine them in a simple calculation. But what we learned about the brain shows that this just doesn't work very naturally. We can do it if we've had training in probability theory and utility theory. We can do it on paper, we can do it with computers. But our brains don't do this very well because the way the brain is structured, there isn't a firewall between cognition and emotion. In fact, our cognitions depend very heavily on our emotions. There's all sorts of interactions that take place. And sometimes that's actually really good because our emotions tell us what matters, what we should pay attention to, what's worth making inferences about. But they also provide us with ways of making decisions based on what's actually important rather than what other people tell us is important. So it's actually a good thing that there are intense interactions between cognition and emotion, except it does make us prone to errors such as motivated inference. Given these problems, how can we actually change people's minds? This is really crucial right now. How can you get people who are running governments like the United States to realize this is a big problem, time is running out, we've only maybe got a decade or two to actually reverse climate change in a way that's going to stop enormous problems? Well, you might think, well, let's give them the evidence and point out that they're subject to motivated inference. The sad thing is this doesn't work very well. We know it doesn't work in politics because people don't change their minds very easily. And we sadly also know from experiments done by psychologists that it doesn't work with anti-vaxxers. Studies were done at the University of California at Los Angeles to see what could actually change people's minds to actually get them to vaccinate their children. And people were kind of impervious to the evidence. And so you might think that the best thing is, well, let's make sure that they understand the explanatory coherence, they understand the evidence, and realize they shouldn't be making motivated inference. But this isn't actually very effective. What is effective, they found in the UCLA study, were things that were actually vivid. They're actually emotionally vivid. So you could get people to vaccinate their children if you show them pictures of children with horrible cases of measles. I mean, that actually can get people somewhat motivated. So we can't just rely on logic to change minds. We've got to have a richer idea of how the mind works. Unfortunately, with respect to climate change, very little research on this has been done. I've got my computational theory, but very little experiment has been done, except for some really lovely work done by Michael Ranney and his associates at the University of California at Berkeley. They've got some very nice experiments show that you can change people's minds by virtue of some dynamic videos. You can find these videos at the website that's listed before. And even with just a minute where you show people how climate change works, and even better with showing them for 4 or 5 minutes, you can actually get people to start changing their minds. So this is just the tip of the iceberg of a psychological investigation that needs to be done to show how you're actually going to be able to produce the changes in people's minds that are really quite crucial. I used to be more optimistic that if you point out the evidence and explanatory coherence, they would do that. But I think you need to have these more kinds of vivid interventions so that people will realize that, oh, that's how global warming works. That's what people are doing. And that's why people have to stop dumping so much into the atmosphere. The other question I wanted to answer, and I've only got just the beginning of it here, is why is it that there are a lot of people who do have the correct belief about global warming, realizing that it's a problem, realize that human control is relevant to it, but nevertheless don't do very much? And of course, I think this is something that all of us are prone to. Until this year, until COVID hit, I would fly to Europe twice a year to give talks, or fly to South America, or fly to China. Well, I'm not flying anymore, but while I was doing it, I'd find various ways of justifying flying at the same time as I knew that flying produces enormous amount of greenhouse gases and thereby contributes to global warming. So there's lots of people like me, even when you can't fly, are doing things such as living in fuel-inefficient homes or driving gas-guzzling cars, who have got things that could be done, but they don't do it. Well, why? Why are people so bad at that? In philosophy, there's a traditional answer to that, which points out a phenomenon called weakness of will. Weakness of will is you know what to do it, but you just can't bring yourself to do it. That's something that everyone's familiar with. You know you should study, but you just don't feel like it. Or you know you shouldn't eat that chocolate cake, but you can't resist. How does that work? A related phenomenon familiar in philosophy is self-deception. People deceive themselves. They think, oh, that chocolate cake isn't that big. It can't be more than 100 calories. So people have ways of tricking themselves. How does that work? Cognitive science can answer these questions. In psychology, these phenomena of weakness of will are called by a slightly more descriptive term, which is intention-action gaps. You have an intention, you know what action you should be doing, but there's a gap. You don't do what you should. One way of dealing with this that experimental psychology has revealed is called implementation intentions. You can say to yourself, when I'm in the next occasion, when I have a chocolate cake ahead of me, I'm going to push it aside and eat an apple instead. So that does some effect. But how does this work? What's the explanation? Well, I think the explanation for this comes from a neural model developed by me and Tobias Schroeder and Terry Stewart. We published in 2014. It's also talked about in my Brain Mind book. From this point of view, once we have a neural theory of how intentions work in the brain and how emotions work in the brain, we can start to see why people are so prone to weakness of will and intention action. So here's the model that's all been implemented computationally in the kinds of methods that Chris Eliasmith developed, where when you have an action, it's not just coming from a simple thought. I should buy a more fuel-efficient car. It's involving interactions among many different parts of the brain. Information comes in from the senses. The amygdala is responsible for lots of interpretation of what's going on in your body, and it's passing information to the prefrontal cortex where you can do high-level kinds of reasoning, but it's not working on its own. It's also interacting with the thalamus, which is also tied in with the senses. The anterior cingulate is important for connecting lots of information together. A big area important for very simple decisions, but also for these complicated ones, the basal ganglia is putting information together and tied in with emotions. And all this has to feed into the motor area where you can actually get your body walking or riding a bike rather than going in a gas-guzzling car. Action, you can see, isn't coming from just reason that might operate in a cognitive area like the prefrontal cortex. Rather, it's involving the operations of all of these. So if you want to change people's actions, it's not just a matter of changing their beliefs. It's a matter of changing the way their brains work by integrating cognition and emotion through this incredibly complicated process. So this is only a beginning of an answer to what you have to do to get people to behave better when they know that climate change is a problem. But at least it points in that direction. And it points to the possibilities of having different ways in which you can change people's behavior. Let me conclude. I hope I've convinced you that cognitive science has lots to say about how people react to climate change. Been able to see how questions about theory choice and denial and change and inactivity can all be addressed from the perspective of cognitive science. We can take theories like explanatory coherence and motivated inference and emotional coherence and use them to explain how people react. So this is enough to establish, I think quite convincingly, that cognitive science has lots to say that is extremely useful for helping us to understand people's reactions and also how to modify people's reactions. Secondly, it's important to recognize that this really was an interdisciplinary enterprise, that all of these theories that I mentioned that have been useful in explaining what goes on in people's minds when they're dealing with climate change have drawn on a bunch of different fields, not just in isolation from each other, but by interacting with each other. So we've seen how psychology, neuroscience, philosophy, computer modeling, and social science can interact. For social science, so far I've just talked about politics, but anthropology, one of the traditional fields of cognitive science, is also highly relevant. Anthropology is important because we need to be able to think about the ideas, the thoughts of not just people in our own Western culture, but also people in other cultures, many of whom are going to be affected by climate change much more than people in the West are. For example, Bangladesh and India are going to suffer a lot more from severe weather and overheating and raising sea levels than the rest of the world. So we need to be able to bring anthropology in as well. I also haven't mentioned linguistics, but that's going to be important because people are using language to communicate ideas about climate change. So it's clear that the explanations I've given have been highly interdisciplinary, not just multidisciplinary. Overall, then, we see lots of reasons to believe that cognitive science is thriving intellectually. This isn't just a matter of the work I talked about today with respect to climate change. I'm hoping to make the same case with respect to COVID-19, but there are many other areas where cognitive science has great successes. One, for example, is in improving understanding of education, where you can draw on psychology and neuroscience and computer models to get much better ideas about how people learn and therefore how they can be taught. So theoretically, I think cognitive science is in great shape. But as the critique I presented earlier shows, there's definitely a need for an organizational revival. There needs to be changes in universities, there need to be changes in the Cognitive Science Society and in the operations of the journals so that the organizational arrangements reflect the really impressive intellectual accomplishments of cognitive science. Thank you very much. Just a couple remarks about the references that I've given for you. I'm giving you the key works by Zivakunda, some of the political scientists, the recent skeptical work by Rafael Nunez. Also, here's some of the work of my own, at least the articles you can find online, and most of the articles can be got various ways over the internet. So I wish you luck in looking more deeply into the question of how cognitive science can be incredibly useful in helping people to understand climate change and what we can do about it.